Let's find the equation of the line that intersects these two planes. This first plane being, let me see, let me switch to the right pen here. 3x plus 2y minus z equals 7, and 3x minus 2y plus 4z equals 2. Now I'm going to refer to this as plane 1 and plane 2. First thing I want to do is just go ahead and jump into Maple real quick, and let's generate some graphs of these functions or these planes to see what we're actually dealing with. What does it mean to talk about the line that intersects them? So I'm going to start off with the command with plots, and that's going to give me the command that I actually need right here, this implicit plot 3D. So I'm going to actually assign the result of the implicit plot to a variable. So I'm going to let a equal implicit plot 3D, and then type in that first equation of the first plane, 3x plus 2y minus z equals 7. And I'm going to take a look at this from, say, negative 10 to 10 on all the axes. So x equals negative 10 to 10, y equals negative 10 to 10, and z equals negative 10 to 10. And let me see, it looks like I don't see any typos, looks good. Now I'm going to assign the variable b to the second plot, which is the second plane. And I'm just going to copy and paste this thing. I think I missed my I. Yep. Put that I in there. And then this was slightly different. This was a minus 2y. And that was plus 4z. And that was equals 2. Now I'm going to display them. And here's the two planes. And when I look at these, you can see where the point that the location where they intersect. There's a line there. Let me see if I can get these spun around and look straight down these planes. Let me see. That's not bad. It looks like two lines. When two lines intersect in R2, it's a point. But when two planes intersect in R3, it's actually a line that you can see right there. So what I'm looking for is the equation of that line, and I'm going to drop in some axes real quick. Let's do boxed. Make it just a tad bigger. There we go. So what I need is the equation, the vector equation of the line where these two planes actually intersect. That's what I'm looking for here. Okay, so I need some points. I need some stuff to work with. So the first I'm going to recognize is that by setting z equal to 0, that will actually give me the point on the xy plane that is actually on this line. And let's just call that line L, the line of intersection for both of those planes. Now, when z equals 0, I end up with a system of equations that will look like 3x plus 2y equals 7, because remember z was 0. And I'll have 3x minus 2y equals 2. Well, I can solve that system. That's a very simple system of equations. That gives me 3x equals 9, which gives me x equals 3/2. Well, if x equals 3/2, that would then imply that if I use the equation 1 for the first plane, that 3 times 3/2 plus 2y, remember z was 0, minus 0, equals 7. And then that actually ends up telling me that y, once I finish up the arithmetic there, is 5/4. So I know x is 3/2, y is 5/4, z is 0, so I know I have the point 3/2, 5/4, 0 that is on the line. Now, since this line L is actually on both planes, it must be orthogonal to both n1 and n2, where n1 and n2 are normal vectors for the first plane and the second plane. Well, if it's orthogonal to those, then I can get a direction vector v, because a direction vector v, I can figure that out by finding the cross product of n1 and n2, because remember, the cross product of two vectors will give me a vector that's orthogonal to both of them. And to do that, I'm going to go back to my determinant. And see, that's going to be 8 minus 2, so I'm going to have 6i. Minus 12 plus 3, so it's going to be 15j. Plus negative 6 minus 6, that's minus 12k. So in other words, I'm going to have this vector 6, negative 15, negative 12. That's my vector v. It's my direction vector. So I have my direction vector. I have a point. So now I know that the equation of the line is going to be, have I used r yet? No, I haven't. Let's just say r is going to be r naught plus tv. Well, we found v, and r naught is going to be that point that we have. R naught is going to be the position vector for this point. So the equation for this line, I can write this as 3/2, 5/4, 0, plus t times v, which is 6, negative 15, negative 12. So there's an equation for the line that intersects the two planes. Now, if I go ahead and write these in parametric form, I see that x is equal to 3/2 plus 6t. If you don't see it, here's my 3/2. This is my 6t. Y is then equal to 5/4 minus 15t, and z is then equal to negative 12t. Therefore, I could also write the symmetric equations. And the symmetric equations are going to be x minus 3/2 over 6 equals y minus 5/4 over negative 15, which equals z over a negative 12. Now again, the nice thing about these symmetric equations is if I'm given any value of x, y, or z, I can quickly and easily find the other two by using these symmetric equations. So just briefly kind of review what we did here. We said, okay, we have these two planes. I can find a point by letting z equal 0, and I picked z equals 0. I could have picked x equals 0 or y equals 0 and had a different point, but the process would have been the same. By finding, or by setting that one value, z equals 0, I can find the points for x and y. So now I have a point on the line. Remember, that point on the line is a point on both planes. Now the two normal vectors to those planes, I can get directly. That might have been that might look a little magical to you. You go back and review the equation of the planes, and you'll see that this is n times x minus x naught. So this is the normal vector's got to be 3, 2, negative 1 to multiply it by that for the dot product. So that's where the 3, 2, negative 1 came from, and the 3, negative 2, 4 came from. So since L actually lies on both planes, we know that it has to be orthogonal to the normal vectors for both planes. And that would give me a direction vector, because finding this cross product gives me a vector that is orthogonal to both of these vectors. So that means that V has got to be my direction vector. And then from there, I just use the vector equation for a line and start substituting in values.